Uh, Today we are going to discuss a new topic, that is decision analysis. Now decision analysis, this portion will be the introductory portion. Now first of all, how do we define decision analysis? This is an analytic and systematic approach used to develop an optimal decision strategy when a decision maker is faced with several decision alternatives. Really speaking, what is really happening in many different applications, some examples are here, maybe in product design, service design, evaluating different financial alternatives, marketing decisions, capacity decisions, sales related decisions. In various situations, what happens when a person has to make decisions, then a few things occur. First of all, there are different alternatives, and these alternatives are to be formed as well, because initially we really do not know what are the alternatives. So, the design of the alternatives are to be done. In order to design, we have to collect data and also models and many different other things. Altogether they can be called intelligence. So, this Herbert Simon's model, which we can call a decision making process, essentially looks like this, that initially there is a thing which is called intelligence. What is intelligence? It consists of data, models, maybe database, model base, and inferences which we draw out of those database and the model bases. So, after intelligence, what we need to do? We have to design what is known as the alternatives. So, alternative design essentially requires that trying to find out from all possible data, information, models, whatever we have got, what are the choices before us, right. Suppose we want to set up a new plant, and we have zeroed in on 5 locations. So, these are the design portion, that there is specific 5 alternatives which are available to us. After these 5 alternatives are available, we have to choose. How do we choose? The choice phase basically means evaluating different alternatives, right. Now, there are many feedbacks, as you can see. Now, while we need to choose, we may find that we do not have adequate data about the design of alternatives. So, we go back to design. Sometimes while we design, we may find no, we need more data. So, you see, we can go from choice phase to design phase, or we can again go from the design phase to intelligence phase, or choice phase to intelligence phase as well. But anyhow, finally, we have to make a choice. And how do we make a choice? What are the different things that are before us? All of these forms the decision making process. So, here is for a typical rational or a normative decision maker would do such kind of things: identify the problem, the decision criteria, the weights to criteria, the alternatives are developed, they are analyzed, the best choice is selected, implemented, and finally, effectiveness is evaluated. So, this is what is usually called the classical rational decision making model. Now, this classical model, although looks very good, and those of us who are very mathematically inclined, we may like to think that this is the best possible decision making model that we can have, but it is not the case. There is another model which, although we are not going to discuss much, but let us know that the so called administrative model of decision maker, sometime also called the descriptive model of decision making, is also not only popular, but probably sometimes the only choice that we have in a complex real life decision making situation. What happens there? In a complex decision making, let us take an example. Suppose we have to come up with a railway timetable. Just imagine a railway timetable for a country like India. How involved is this? We have to take all the different kind of trains, the express trains, the local trains, the goods trains, the different other constraints like engine is available or not, the different other like signaling system. So, there are hundreds and thousands of constraints. So, under this situation, if someone really thinks that we solve a mathematical model and then we come up with a solution to come up with a very viable schedule, it may not be possible, right, because here is a situation where we have incomplete as well as imperfect information. So, and not only that, the people who make decisions, they are also constrained by bounded rationality. What is bounded rationality? They do not have enough information. They are in a given situation only, they know only one part of the system. So, when that happens, it is not possible for a person to really look at the entire complexity and come up with a solution. So, what usually is done under such situations, the people really go for what is known as satisficing, right, rather than optimizing. So, instead of really trying to find an optimum solution, people would rather go for a satisfactory solution. It is like, suppose we have a few choices, look at what are the different alternatives or choices before us, and look, is there any alternative which really supports most of our causes, right. If we find yes, here is one which does most of the job, go for it, right. So, that is the descriptive model of decision maker, and most of the real life situations people really go for satisficing because there is bounded rationality, right. But knowing that, let us look at what exactly how can we really help people who have to make decisions, particularly who have to come up with, when there are several choices. See, when there are several choices, a very common word is what is known as payoff. So, I have these different alternatives which may likely to occur, and these are the likely payoffs. So, we have to come up with those payoffs. We will discuss that more later, but let us understand the decision environments can essentially be of three types. What are they? It could be one with certainty, one with risk, and the other with uncertainty, right. So, what happens when the decision making environment is certain, then ambiguity and chance of making bad decision is low. When it is under risk, it is moderate, and in uncertain situation it is high. What is the difference? The difference is, look here, we talked about in the first diagram the design of alternative and then choosing between them. Now, you see what happens when we have to design the alternatives, the which alternative we should really choose, it depends on another thing which is known as the states of nature. What is states of nature? States of nature is something which is not in our control, all right. So, suppose we have to make really three decisions. Let us say we talked about plant location problem and we identify three cities. So, one of these three cities or four cities we have to choose from, but different situations may occur. What are the different situations? Let us take something like one situation was could be that liberal government policies, the government policies are going to be very good, liberal. Second could be that government policies are going to be adverse instead of positive or liberal, and third possibility could be that government policies will be as usual. So, we have no control on these, and that is why they are called states of nature. So, when we have such kind of states of nature, if we know the which state of nature is exactly going to come, then it is a decision making situation under certainty. If we know that the decision making situation is probable, the states of nature are having certain probabilities and the probabilities are known, then we call it is a decision making situation under risk. But when the decision making situation is uncertain, then these probabilities are not known, right. So, when the probabilities are not known, then what really happens is that, let us go back, that is the decision making under uncertainty. When probabilities are not known, then we have to have certain other kind of strategies for decision making. So, we will discuss them one by one. Let us look at first the decision making under certainty. Here the alternatives are known with certainty, the outcomes are also known with certainty, right. So, we know the alternatives, we also know the outcomes. So, since we already know the alternatives and already know the outcomes, the decision making is therefore straightforward and there is no ambiguity. Please do not get confused between the straightforward and no ambiguity with simplicity. It does not mean the problem is very simple, the problem can still be quite complex, but the advantage here is it is solvable, right. So, like linear programming, you have seen there are a lot of linear programming problems which are quite complex, right. There are large number of constraints, the objective function could be very difficult one, sometimes you have to linearize it, and there are many different constraints that can come in a given situation. But whatever it is a decision making under certainty, not I am saying all linear programming problems are decision making uncertainty, but whenever the alternatives are known, the outcomes are also known with certainty, it is basically the challenge lies in the mathematics, but not in the formulation, right. So, those are the situations which can be called decision making under certainty. Other examples could be the AHP process or the so called economic order quantity, economic production quantity, EOQ, EPQ models. There could be 100 other examples, but these are some examples of decision making under certainty. Now, let us look at decision making under risk. As I told before, in decision making under risk, the states of nature are known, but we do not know what are their exact probability. So, if you look at from this angle, then alternatives and outcomes are known, but alternatives to outcomes known only with probability associated with them. So, how the outcomes will vary? Because as I said, the different states of nature may occur, and if one state of nature occur, one sort of outcome will come. If another state of nature comes, another type of outcome will result, and they are associated with, that means the states of nature are associated with certain probability. Going back to our previous example, maybe the liberal government comes, has a government policies will be 40% probability, adverse let us say 20%, and business as usual the same policies may be another 40%, right. Now, we really do not know what is going to come, but we can assume these probabilities and come up with suitable payoff values in this kind of situation. So, this therefore is called decision making at risk, right. Decision making under risk or decision making at risk because of the ambiguities due to the probabilities. So, this is the decision making under risk. But what happens under decision making under uncertainty? Here the alternatives and outcomes are also sometimes not known with certainty. Look here, those kind of problems are called unstructured problem. See, there are two types of problems, one can be called a structured problem, the other can be called as an unstructured problem. If we have a structured problem, in a structured problem what happens? The alternatives and outcomes are known, but suppose even alternatives and outcomes are also not known, then what can we do, right? We really cannot do much under that situation. So, we have to really come up with alternatives and outcomes, but here there is a very important thing. There are lot of uncertainty problem where we try to put a structure by arbitrarily assuming alternatives and outcomes. See, alternatives sometimes can really be fixed, but outcomes may not be known. But do we fit a model just because we have to fit a model? This could be the biggest mistake. Sometimes if we really do not have information, really do not have any means by which we can actually compute outcomes, it is better to keep it like that, and put the final decision as an if then else logic, right. Rather do what is known as scenario generation, like some sort of perspective we have to really bring, but not really try to force upon certain alternatives and outcomes, or in other words do not try really to put a structure into a problem that do not have any structure, right. So, having said that, if suppose a structure can be put, that means we can actually come up with alternatives and outcomes, then the problem become a little simpler, but again the other problem comes that we really do not know the probabilities. So, because we do not know the probabilities, we do not know which state of nature is going to come. Going back to the kind of problem I was referring, suppose we have to make decision from 3 plants A, B and C, and which plant are we going to choose? We know there are 3 states of nature: the liberal government policies, the adverse government policies and usual government policies. So, we do not know which is the probable state of nature. In that sense, it is an uncertain situation. So, therefore, we since we do not know the probabilities, it really is a uncertain problem, and because of high ambiguity. Now, in subsequent classes we shall take up the kind of different criteria for decision making under those uncertain situations. So, while we discuss, we shall be taking up really 5 different criteria. What are those 5 different criteria? The first one is the Maximax or optimism criteria. The second one is a maximean or pessimism criteria. Third one, which is called Harvey's or criteria of realism. This particular criteria is really a mix of the maximean and maximax. I will discuss this a little more. The fourth one is the so called Laplace or equally likely criteria, and finally, the Savage or the minimax regret criteria, right. So, they are different criteria for decision making under uncertainty. The first one is called the Maximax or optimism criteria. At an appropriate point we will discuss these in detail, but at this point let us only say that in the so called Maximax or optimism criteria, the decision maker tend to believe that the best state of nature is going to occur for each decision strategy. What exactly it means? It means that as we have said, let me draw a diagram, that is, the diagram is that these are my decision alternatives. A, B, C, and these are my states of nature. And all of these are payoffs. Right. So, please look at this carefully. What we have, that let us say that the decision maker is an optimist. When the decision maker is an optimist, or basically he is a maximax operator, what he does, the decision maker really believes that suppose he goes for A, then the best possible state of nature will occur and he will get the best possible payoff under that situation. Similarly, if he suppose it is B 1, if he goes for the decision alternative B, again he will choose the best possible payoff under a state of nature, means he believes that particular state of nature may occur, maybe P 2. Let us say when he goes for C, he believes again the best possible state of nature will occur and he might get the best possible payoff. So, he will believe that usual scenario will happen and he will get P 9, right. So, these are the kind of things that may happen when a person is a Maximax operator or an optimist. The second one, when a decision maker is a pessimist, at that time the decision maker tend to believe that the worst thing may happen. Is it all right? So, there is a difference between a Maximax operator and a Maximean operator. The Maximean thinks that the worst state of nature is going to happen and he or she is likely to get the worst possible payoff for every decision alternative. Harvey's is a mix of the two. What is the mix? Mix is that the decision that comes out from a Maximax criteria and the decision that comes out from a Maximean criteria, the Harvey's decision maker really comes up with something which is an in between thing, right, based on a factor which is called a degree of optimism. The next one is what is known as the Laplace or equally likely criteria. A Laplace decision maker would put equal probability for each of the states of nature, right. So, if you again look here in this particular thing, that the the Laplace decision maker would assume that liberal government policy will have an 1/3 probability, adverse government policy will also have 1/3 probability and usual scenario will have a 1/3 probability, right. So, that is about the Laplace decision maker. The final one, the Savage or the Minimax regret criteria, essentially trying to find out what is the regret of not able to make the best possible decision, right, for each scenario, and then form a regret matrix and really try to minimize regret, right. So, that is what happens under such situations. The second situation, when we have decision making under risk, at that time the approach we usually follow is known as the expected value approach. The expected value approach, sometimes it is also known as an expected monetary value approach. What really is done there? The probability of occurrences for each state of nature is computed, right, and then for using those probability of occurrences, if we multiply these probabilities with the payoffs and then take the sum for every state of nature, then we can come out with something like an expected value, right. So, these expected values are to be calculated for all states of nature and for every decision alternative, right. After obtaining all the different the sum of these expected values, the sum of P I into payoff which comes out to be the expected value, select that decision alternative which has the best expected value. So, this is how we take decisions for decision making situations under risk. Now, please understand one thing that falls out automatically, that what is the payoff that we are getting in the form of an expected value if the person becomes an expected value operator, and what is the maximum payoff that a person could have got, right. So, it is like supposing the best states of nature would have come and everything gone in the best possible manner, the people, the decision maker could have got a certain amount of payoff, that expected value of perfect information is the maximum amount of decision maker would pay for additional information. So, basically really what it is the kind of the maximum possible value which you can really get if you would have taken the best possible decision minus the kind of decision that you have already taken, right. So, the difference between what you have got, I mean what you could have got if the best possible decisions were taken and what you have actually got, right. The difference between the two, that will determine the expected value of perfect information. Sometimes it is simply called value of information, right. So, it is like let us say in a share market situation, you have bought a particular share, you have got a certain amount of payoff, but suppose you would have bought the best possible shares, what is the payoff that you could have got, right. Suppose you have got something like 100 and you could have got 200, the difference is the value of information, right. What is the importance of the value of information? This is also can be shown is equal to the minimum expected regret, and this is also the amount that you would have paid, right, to buy information. Suppose someone tells you, you are buying this share, do not buy something else, you will make more profit, but you have to pay me some money, right. If you can believe that you can make 100 additional money, you can pay 20 rupees for buying that additional information. That is why this difference is called the value of information, right. So, this is another very important topic which we shall discuss. The third most important thing that we are going to discuss is the Bayesian analysis. Really, when we have probabilities and after having the probabilities, if you have new data on the basis of an experimentation, then the prior probabilities gets modified to what is known as posterior probabilities. So, really what happens, you know certain probabilities about the states of nature, you do an experimentation, based on experimentation you get some new data and those new data helps you in getting the posterior probabilities which can really help us in making better decisions. So, quite a portion of our study we shall really focus on what is known as the Bayesian analysis. Finally, you can see the kind of diagram which we can draw, which we can call a decision tree analysis with what is known as the Bayesian analysis. So, you can see at the very first there are two options, either conduct survey or do not conduct survey. If you conduct survey, then you can get favorable result or unfavorable result. If you do favorable result, you get one type of payoffs. If you get unfavorable survey results, you get another kind of payoff. So, what kind of payoff are you going to get under different situations, and putting them together that could be what is known as a decision tree, right. So, really starting from decision situations, we shall try to understand the different situations under certainty, uncertainty and risk, and then put them together into a payoff matrix, obtain calculations for different kinds of decision makers. Then we can have experimentation in the form of a Bayesian analysis, put them all together in a decision tree and then finally evaluate what kind of decision a decision maker should be making, right. So, all these can really help decision making situation in practical situations, and therefore, it is a very important subject, right. So, we conclude here the introduction portion. Thank you very much.